In this video, we are using math and statistics to help us predict NFL outcomes throughout the course of the season. It is week 5 of our video series that we have going on, and I apologize, I missed week 4. That's because I had to move and I had things going on in real life, but that's neither here nor there. In this video, we are going to discuss how our model works, what it has thought over the past couple weeks, how we've been using it to beat the sports books, and what changes and iterations are going to happen on the model so we can continue to win and make this thing more accurate. So without further ado, let's get right into the video. So to kick things off, I just want to go over how the model works currently, and it's a relatively simple process. So it takes raw statistics that the NFL makes publicly available. We convert that, process that information into a rating system that I'll go over how it works. We add some contextual adjustments, including quarterback impact and the home field advantage that a team may or may not have. We then feed it into a matchup system, which we are able to calculate expected points from each team using a Poisson distribution model. And then from there, convert all of that information into a win probability of who is going to win the matchup. It's a really fancy way of trying to decide who's going to win a game. So we're going to use the Buffalo Bills in this example. And here you see we take the raw information from games, which this is exactly what it looks like in Excel. And the information that we're taking is the average that a team scores at home, the average that they score on the road, the average that they allow at home, and the average that they allow on the road, because we're splitting each team up into offense and defense and then away and home, right? So let's just say that the Bills are playing at home. So at home, we're going to calculate their at-home offense and their at-home defense using a z-score. And a z-score is a way to basically compare a whole bunch of people compared to an average. So we're able to use a metric system that's easy to follow and an easy way to figure out who's good and who's not. So the formula for this is you take the Bills' average that they score at home, you subtract the league average, and then you divide that over the standard deviation. And in this case, their at-home offense has a score of plus 0.54, which means that they're about half a standard deviation above average, which is pretty good. They have a very solid defense, statistically speaking. Offense, excuse me. We do the same thing for their defense, and in terms of defense, a negative number is better, so negative 0.7 is actually a good thing. It doesn't mean that they're worse, it means that they're slightly better on defense, but negative 0.07 isn't great. That's really right around average. From there, we add the context, which what we have so far in our model is the home field advantage and the quarterback impact. So we'll go into how home field advantage works statistically and mathematically speaking. To calculate home field advantage is something that you can actually calculate and not just something that we imagine, right? We imagine it exists, and that's because it does, but it doesn't exist for all teams. Some teams actually don't play better at home, and the numbers allow us to see which teams do have a home field advantage and which teams don't. So we take the average that they score at home, and we subtract the average that they score on the road. So for the Bills, they score on average 4 points more at home than they do on the road. And the same thing with their defense. How much do they allow at home versus how much do they allow on the road? And you can see that the Bills allow 8 less points at home, which means that their defense plays significantly better at home. We then put that into a z-score so we can compare all the teams to each other on sort of an averaging system. And then from there, we see that the Bills have a home field advantage of 0.10, which isn't massive. Some teams have a really big one, like the Broncos. I think theirs is 0.40. And some people actually have a negative home field advantage, despite what everybody thinks, and that's why the numbers are so useful. We also have our quarterback impact. So Josh Allen, great quarterback. How much of an impact does he have on the game? And that's something that we're trying to quantify using math and statistics. So we take QBR, which is an arbitrary statistic that ESPN has kind of made up over the years to judge quarterback performance. Josh Allen has an average quarterback rating thus far of 71.83 over the course of 2024 season and 2025 season. We then subtract that against the league average quarterback rating, which is 47.93. So he's way better. But then we divide that over the standard deviation to give us that z-score thing that we keep talking about. And we see that Josh Allen has a 1.36. What does that mean? That means that Josh Allen is almost 1.5 standard deviations above the average quarterback in terms of QBR, which means he's really, really good, which is why he won the MVP. I think the only person who has a slightly higher one is Lamar Jackson. From there, how we put that into our model is kind of created this arbitrary term called quarterback impact. And we use, there's QBR, and we multiply that by K. And in this terms, K is a scalar that I'm using to affect the team's rating. And that's a number that I can change, right? Currently, right now, it's at 0.1, which means that the quarterback performance makes up about 10% of the team's performance, right? So 10% of how we judge a team is based on QBR currently, and I think that it should actually be a lot higher. So in this context, the Bills get a performance boost of 14% with Josh Allen as their quarterback. Finally, we take all of those metrics, home field advantage, all the strengths ratings that we calculated, we combine them together to get an adjusted rating, which is the Bills here. This is their new adjusted rating that we're going to use in a matchup. And we do this for every single team at home and on the road for offense and defense. Moving on. So let's go through an example in a matchup. So this is one that happened, I think, week 3. You have the Dolphins versus the Bills. So we take their adjusted ratings matchup, which is Bills at home versus the Dolphins on the road, because they were in this case, and we see the Bills have 0.804 and the Dolphins had a negative 175, which, just looking at that, you can see who you think is going to win the game. Obviously, everybody without these numbers thought the Bills were going to win, and that's what they did. We plug that into a formula where we basically take E and we raise each of those teams' ratings, divide it over each other to get probabilities of what team we think is going to win in that matchup. And in this context, in this matchup, we had the Bills having a 72.7% chance of winning that matchup. And obviously the inverse of that, because all probability outcomes need to equate to 1 or 100%. You just subtract the Bills to get the Dolphins' probability of winning that game, which would be 27.3. That's what our model is predicting for this matchup. Now, using the Poisson distribution model is a way that we can kind of estimate how many points we think each team is going to score, which is something I'm going to discuss a little bit later and why it's useful for us as sports bettors. But for this particular matchup, we thought that the Bills would score 27 points and the Dolphins would score 21. Let's compare that to what actually happened. We had the Dolphins score 21 points and the Bills scored 31, so not too far off. And that is the power of math and statistics. Now, I want to discuss briefly why I built this model and how I'm using it. I'm using it to beat the sports books. All this stuff is to basically find edge and earn money over a long period of time, right? We're not just trying to throw Hail Mary plays and pick up some random parlay and try to make $1 billion overnight. No, we're trying to be in this thing for the long run, which is why we built a model to help us in our decision-making ability to constantly find edge in the market and find discrepancies between these sports books. So what we do is we take the sports books odds for each matchup, we convert that into implied probability, we remove the VIG, and then we compare what they say to what our model says. Finally, we use the Kelly criterion bet sizing, which is a formula some guy made up. I don't really know all the math behind it. And then we use that to place our bets and come up with our outcomes. So I'm going to go through an example here quickly. So for week 4, we had the Seahawks versus the Cardinals. I use Hard Rock Casino because I live in Florida and it's the only one available for me. And they have the Cardinals at plus 110 and the Seahawks at minus 135. When you take that and convert it into implied probability, they're saying that the Cardinals have a 47.6% chance of winning that game, and the Seahawks have a 57.4% chance of winning that game. When you add those numbers up, you have something above 100. That extra 5% is the VIG, or the juice, that the sports books adds to all of their matchups to basically make a profit regardless of who wins the games. That's kind of their cut for being a middleman, because sports books aren't technically you versus the casino, it's you versus another bettor, and they're kind of facilitating it, acting as a market maker. If you're familiar with all those terms, then this should make complete sense to you. If you're not, maybe in another video I'll go deeper into those topics. But basically that 5% is the sports books cut. So what we want to do for us, because we're trying to make the right decision, is remove that 5%. So we use this formula, which is their implied probability over the total, to get what we call a fair probability. from the sports books, which in this case would be 45% chance that the Cardinals win and 54% chance, 56% chance that the Seahawks win that matchup. I would then take that, compare it to what our model says, and from there I would make my own decision on how I'm going to place a bet. Now, things that I'm using, things that are going to change to the model, updates that are happening, is going to be, we're going to have a lot more raw information that's going to feed this model. You saw all the data that we feed it, which is the home field advantage, the home allowed, defense allowed, et cetera, everything we went through in this video, and what's going to be upgraded and changed to this thing to make it a lot more robust is we're going to add all of this. And I'm going to switch it from Excel to code and work on my first major Python project, building this thing out. So we're going to add a play-by-play system, which is going to include red zone efficiency, fourth down efficiency, third down efficiency, success rate, etc. These are all statistics that we have for each team that I'm going to start to employ into the model. We're going to have wide receiver separations, we're going to have O-line versus D-line win rates, we're going to have pressure percentage, coverage types, tackling efficiency for each team. All of this is going to be added to the model so we can make better predictions on who we think is going to win. Injuries in depth, a huge one as the season continues to go on. It's already week 5 and it feels like so many players, so many key players are injured for every single team. This is going to be a huge one that we need in the model ASAP. Situational context, not as much, but still important to have, which is like rest days, short weeks, travel time, how much they're traveling in between games, the altitude, again, the Broncos, weather of the game, all these things have an impact on the game. I think there's a famous quote that says, when there's a lot of variables, a lot of variables need to be considered, and predicting these games, there's a lot of variables. And then team style, pace, special teams, all things that we're going to add as raw data that we're going to process the same way that we're doing right now and help us figure out who's going to win so we can make more money. So then we're going to have some model upgrades that come along with it. So next time it won't be in Excel, it's going to be in Python. But we're going to add an ELO with time decay, which is basically something that we already have, but it's just a weighted ELO ranking system for each team, weighing the more recent games a lot more than what happened last season. All these things on screen, you can see. I'll probably go into a little bit later in another video once it's built out. And I have some examples to show you on how each of these functions are going to work within the model. Finally, we're going to add some validation and some reports, basically some back testing to the model so we can run simulations on the games before they happen to have even more accurate decisions. Basically, the computer is going to go simulate the game 1,000 times, give you a summary of what happened, and then from there you can use that to help make your decision on what you think is going to happen. And then last but not least is make this thing a multi-sport expansion. I love football, but I also like other sports, and as a sports bettor, the NBA is coming up, which means there's a lot more opportunity to make money. There's 82 games compared to the 17 games, which multiply that by all the teams that play in the NBA. You can just see there's an abundance of opportunity. Baseball is coming to an end here soon, but we have the NBA to count on, and I plan on building this model out and keeping this thing going, not just for the NFL season, but for the NBA season and for the next one and the next one and the next one, because I'm already 6x up on my money just this NFL season. So we're going to keep it going. The good times are running, just keep them going. And at this point, has it been luck? Some of the plays have been luck, but a lot of it has been because of the model. So with all that being said, let's get into the model and give our predictions for this week. Quickly review what happened during week 4 because I didn't make a video, and then wrap this thing up. So this is what happened for week 4. I didn't make a video. I was busy moving, but you can see that we had a 66% correct prediction rate, right, for week 4. We had a couple upsets, maybe some ones that were a little more obvious in hindsight, right? The Panthers versus the Patriots. The Patriots have been really, really hot. The Eagles versus the Bucks. I thought the Bucks could have won that game. Obviously, it didn't happen. Texans versus the Titans. I don't know why the model thought the Titans would win that game, but I'm just keeping everything fair. And then the Giants versus Chargers was a little bit of an upset. So no harm, no foul, still 66%. If you're new here, last week we had 62.5%, and the week before that we had 75%, and week 1 we also had 75%. So we're trying to keep our numbers up there. Getting into week 5, these are our predictions for week 5. If you want to pause the video, kind of take note, do whatever you want to do with this information. But one last note that I want to make about these predictions is that this model has no context, right? You and me as human beings, we have a lot more information coming to us on a continuum, right? You watching this video is you gaining information. Every time you open your phone, you go on a website, you listen to the sports shows, you see somebody got injured, you're gaining information on a continuum. This model only has fixed information, what I feed it, so it doesn't know the full context of the situation. And that's why I wrote these notes for these few predictions. The Rams versus the 49ers. No context on that prediction. It's saying the 49ers are going to win. I don't necessarily agree with that. You take it for what it's worth. Ravens versus the Texans. Of course it's going to say the Ravens are going to win, but the Ravens have lost Lamar Jackson and their whole defense is injured. This model doesn't have that context. If it did, it would probably say the Texans have a better chance of winning that game. The Bengals versus the Lions, again, sort of the same thing. Joe Burrow's out. He's injured. They haven't been playing the same. Their backup quarterback's not even comparable. Without Joe Burrow, the Bengals are basically cooked. Do I think they're going to win against the Lions? Absolutely not. The Lions have been on fire recently. So again, no context from the model. You have to take these things with a grain of salt and just use it as an additional data point if you're going to use this to help you make sports betting decisions. Now, finally, last thing I want to touch on is this Poisson distribution model and why it's useful. One thing, if you're a sports bettor, that you need to be doing is making parlays. One of the easiest ones that I've been doing is taking who you think is going to win the game and then total points scored by the teams, right? Always pick something that's low, that is conservative, because you have a higher success chance of winning. If you win more than you lose, you're going to win over the long run. And you don't want to be doing degenerate things with your bankroll, right? Don't be going all in on some random 10-leg parlay. That's how you go broke, and that's how you're part of the 97% of people who never make money over the long run in sports betting. You want to be smart, you want to be efficient, you want to use tools like this, you want to use the Kelly Criterion bet model. This is how you're going to get ahead. This is how I've 6x. I'm being honest, and I plan on turning that to a 10x, a 20x, a 30x, literally throughout the course of this season by using this model in my assistance, being smart, not being undisciplined, not being reckless. It's a real way that you can make, a substantial amount of side income. So I highly recommend that you do a simple 2-leg parlay. Take a team that you think is going to win, and then just do a conservative total points that you think the teams are going to score. That's a really simple one that can hit with a very high win rating. For this matchup, the Jags versus the Chiefs coming up, my model's saying that the Jags are going to win. Do I think the Jags are going to win? Take that with context. I personally don't. I think the Chiefs are going to win. I would put Chiefs are going to win this game, and then I'm going to do total points. I'm going to do above 40, right? That seems right. And then maybe on game day, I'm like, I don't know. Maybe I'll go with something even more conservative. Then maybe you can turn that into a 3rd-leg parlay, and you can do Patrick Mahomes is going to throw more than 175 passing yards, plus the Chiefs are going to win, plus the total points is going to be above 35 points. That's a really conservative play that will probably hit. Anyway, that's what I've been doing, and that's how I'm going to conclude this video. Take everything from this video with a grain of salt. If you want to see the updates that are going to continue to happen into week 6, week 7, week 8, etc., into the Super Bowl, into the next sport, subscribe, like the video, and I'll see you in the next one.